Hi everybody, today we're going to take a look at trig functions, sine, cosine, and tangent only, and we're going to look at their parent graphs. And from the parent graph, obviously, is how we get the pattern of how we're going to graph all the transformations and really as moving forward. So we're going to take a look at just the sine, and really the easiest points on the sine are the quadrantals. So we know that sine is the y value, so that's what we're looking at. So I'm going to put the graph up here. At 0, 0. This is, of course, pi over 2. Now we have to look at the scale. Every fourth line is 1 pi, so one line is 1/4 pi. So 2 lines is a half a pi, and half a pi goes up to 1. Now we're back over here. Here's pi. Pi, we're at 0. And then down at pi over 2, we're down at -1. And then back at 2 pi, we're back at 0. And so the thing with the sine and the cosine graph specifically is that it has to run through a whole cycle. So for example, let me get rid of this. The graph cannot just turn around and go back up. It has to go all the way down before it's allowed to come back up. So therefore, it's kind of easy to predict. It's a periodic function, so every so often, the values repeat. And it has to run through the whole cycle. It has to come all the way down before it's allowed to go all the way back up, and then it's allowed to go all the way back down again. So remember we talked about how to measure the period. You want to measure the period from either high to high or low to low. Be careful with measuring it from 0 to 0 because, like in this case, if we did from this 0 to this 0, we'd only have half the numbers. We'd only have negative values, which we obviously know sine is allowed to be positive as well. Some other things when you draw your graph, please make sure you draw it smooth and curvy. Don't draw it pointy. It's not absolute value. The equation that we're going to use is y equals a, and then the word sine will be there, the letter b, and we have x minus c plus d. Now, we have some exact same things we've always had. A is really the vertical stretch, but we don't call it vertical stretch with trig graphs. We call it amplitude. Amplitude should always be positive. Amplitude, as you know from looking at just periodic functions, it's the distance from the midline up or the midline down, and it is always positive. What's new about trig graphs is this letter b. The letter b doesn't really appear in the graph anywhere. Instead, it's how we figure out the period. The cycle for one entire cycle is 2 pi, but we have to divide that by b. Furthermore, we have to divide it by the absolute value of b because your period is always positive because it's a straight line measurement. Now, the other two measurements inside the parentheses control left and right. So if you have a minus c, that's going to be right. If you have a positive c, that's going to be left. Whatever, pi over 2, 2 pi, whatever it happens to be. And then, of course, the number that sticks out, this is your up and down. The way it's written, a positive d would move it up, and a negative d would move it down. So you do have to know how to graph the cosine and the sine. And obviously the tangent. And we'll go through that there at the end. Let me get rid of this so that we can use that space later. So for now, when we graph the sine, this is how it's going to go. And we'll go through this again. You're going to go 1, 2, 3, 4. This is where the period goes, on the fourth half little tick mark. Also, I'd like you to mark the halfway spot. A lot of things happen at the halfway spot, and I want to know that you know that's what it is. Now, on the y-axis goes the amplitude, whatever it happens to be. For the parent graph, the number in front of sine would just be, right, it's just y equals sine x. There's a 1 in front of that, so we'd have to have the 1s. So sine is 0 in the beginning, middle, and end. Sine goes up and then down. So it goes up between the first two zeros and down between the second two zeros. And that's all we're going to do to graph it. We're not going to calculate anything. We're not going to adjust for anything. We're going to fix the axes and then put the graph on there. So we graph trig functions quite a bit different from any other function. We control the axes and we make the graph the same every time. So let's take a look at cosine. Again, with some cosine values. I didn't write the parent function on here. This is y equals the sine of x. This is y equals the cosine of x. So if we take a look back at our unit circle, because that's what you're good at, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So for cosine, at 0, it's actually a pi. And then as we move up to pi over 2, it goes down. So if it starts high, the only place it can go is down. So it has to go down. Furthermore, it has to go all the way down to negative 1 before it's allowed to run all the way back up. So cosine starts at the top and works its way down to negative 1 and then back up to positive 1 again. So if we flip this over and do it negatively, obviously if this is the top right here, we have to move it so that it goes down, and then at negative pi it's back at 0, and then we're about to come back up and come back down. And again, when you draw it smooth, please. Maybe my points are just large. I feel like that looks a little weird. So the transformations are going to be the same. We have y equals a cosine of b, x minus c plus d. So these are all 100% the same as they are for the sine. Tangent is not the same. And so we have, obviously, negative c is the right, positive c is the left, positive d is up, and negative d down. So let's get into how will you draw this graph. So again, 1, 2, 3, 4, period. Halfway. Please mark that, half of whatever your period is. Amplitude will go here. Now for cosine, it starts high and it ends high. Halfway, it's at its low mark. In between the high and the low, obviously it has to go through 0. And that's what your cosine graph will look like. We will draw it only for one cycle, and so it will look like that every time we draw it. It might be taller or a little wider, but it will look like that every time. And finally, we get into tangent. Tangent is very, very unique. It does not look like the others. Let's talk about the graph. Tangent, remember, is slope. So your slope here is 0, your slope here is 0. Up and down, this slope is undefined. How do we graph undefined? At pi over 4 is another easy number to graph. It's a 1. All right, so there's pi over 4. At 3 pi over 4, it's negative 1. 5 pi over 4, it's back up to 1. So let's see if that helps us, because we do have pi over 4s on this grid. So we have same stuff. It looks the same. It just behaves differently. So we have y equals a tangent b x minus c plus d. Oops, that's a d. So let's get into this graph. At 0, it's 0. At pi over 2, at pi over 4 rather, it's a 1. So we know it goes here. At pi over 2, it's undefined. Undefined will be an asymptote. At 3 pi over 4, which is the next line, it's actually a negative 1. So it kind of jumps and comes back down here. And then we get back to pi, all right, here, it's at 0. And then it goes back up to positive 1. Then we have another asymptote at 3 pi over 2. So the asymptotes make it bend. So this is not just a straight line, it will bend because the asymptotes sort of prevent the graph from touching or crossing it. So when we're going to graph this, we're actually going to start this at negative pi over 2. So we're going to think of this as negative pi over 2 down here. Tangent lives here and here. So the first cycle is really from negative pi over 2 to positive pi over 2. So you're going to have to draw it to the left. Amplitude here is undefined. It has arrows. It goes all the way up to the top. The period is 1 pi over b. So this is really hard to remember. It's very easy to just use 2 pi over b, but it's 1 pi over b. Negative c obviously takes this to the right, and positive c takes this to the left. Vertical, this is still positive d is up, and negative d is down. So how are we going to draw this? Well, maybe we're not going to. Okay, no problem. Just draw it over here. So you're going to have your axes. You're going to go 1, 2, 3, 4. You're going to double the period. This, I promise, will make it easier to graph. So this is 1 pi. Then we have to also go negative. The pattern for tangent is one line to the left is an asymptote, and then it goes asymptote, 0, asymptote, 0, asymptote. For tangent, you're going to always draw 2 cycles. So you're going to have to draw the same thing twice. This will just help. It makes it easier when we start moving it, honestly. So if you just double it all, it makes it a little bit more consistent. Then we don't plot any more points. We just draw it in because we know that it looks like this. So you don't have to plot points. So you just plot the asymptotes and the zeros. So there's your sine, cosine, and tangent paragraphs. We will work on all the transformations in class.